Okay, spiral matrix. Let's do it. Now, given a matrix of n times m elements, n rows, and n columns, return all elements of the matrix in a spiral order. For example, given the following matrix 1, 2, 3, 4, 5, 6, blah blah blah, you should return 1, 2, 3, 6, 9, 8, 7, 4, 5. Okay, very straightforward. So the difficulty of this problem is that, just checking time, we need to keep track of the boundaries, these 4 boundaries of the matrix. So first of all, well, we need to now, without further ado, I feel like this is gonna take a long time, so I probably won't have enough time. If I have enough time, I'll explain it. I'll explain my thought process in the end. But right now, I'll just like go with it. So now we have a list and create a new linked list, right? Integer. And also we need to keep track of the boundaries. Now the first boundary is going to be a row start, right? So this is the top row, which is equal to 0, and row n is equal to matrix dot length minus 1. So this is the bottom row, right? And we also need a column, so which is column start is equal to 0, and column n is matrix 0 dot length minus 1. So we got the leftmost column and the rightmost column. Now it's time to start iterating the iteration. So the while loop, so when do we stop? So when row start is still less than and equal to row n. Or let's not forget the columns. So n column start is less than and equal to column n. So the first iteration, the first iteration is the top row. So for I equal to 0, so the row stay the same. What's moving is the columns. So when I is equal to 0, I less than or less not or less than and equal to column. Well, wrong. So we start from the left boundary. So this is column start, and this is column n, and I plus plus. We're gonna add result, add matrix. So the rows stay the same, so it's stay the same. The row start and I. So this is the column. And after that, we should update it. So we have been through the first row, so row start should increase by 1. Now the next one is the end column. So I equal to, now this time the column stays the same. The column doesn't move. What's moving is the rows. So it's row start. Row less and equal to row end, and row plus plus. Same thing, we're gonna add the matrix, the elements to the list. So this case, the x-axis is the I, and the column is column end, right? And now we've been through the column n, we should update it to -1. not minus 1. We should decrease it by 1. So now here's the tricky part. Right now we've been doing one increment and one decrement. We need to make sure that the row start is still larger than row n, row start is still less than row n, and column n is still larger than column start. So whenever you do a number data manipulation, you always need to check that if you exceed the boundary or not. So you say if row start is less than or equal to row n, then that's perfect. So we need to iterate the bottom row. So for I equal to 0, I, not this time, so I is column n. I is larger and equal to column start, right? And I minus minus. Same thing, we're gonna add this element. We're gonna add every element at the bottom row, which in this case is row n and column, no, just I, right? So after this, we need to update it, right? So now we've been through the bottom row, so row n will be decreased by 1. So same thing here. So if row, column, and start is still less than and equal to column n, what we're going to do is for every element at this column, right? We're going to do, now it's time to do row n and I larger and equal to row start and row minus minus, okay? So same thing, we're going to add the element to the row matrix. So the column doesn't move, right? The column doesn't move. What moving is the x-axis. So this is column start, okay? So now we've been through column start. It's time to update the column start, so which is plus plus. Okay, so now we've done the iteration. It's time to return result. Okay, so let's check. Looks good to me. Let's submit it. Okay, it's done. Runtime error. Index out of bound. Oh, I forgot to check for 0. All right, so if matrix dot length is equal to 0, or matrix 0 dot length. I think this is at this edge case is kind of well, it's not stupid, but it's reasonable because people can put in 0 input. It'll return null. Okay. I think we should return a result, right? So this should be on top. Accepted, perfect. Okay, so the point of this is to try to keep track of the boundaries. Anyways, thanks for watching. See you next time.